same time, it's not overly useful once we've decided that everything works the way we want it to. Therefore, let us quit and bring up one other GLOW file. Now, one of the powers of GLOW is the fact that it can handle different layout sets. So, while our main layout set is going to be that one, dealing with DBX itself, we also want to have perhaps another layout, in this case to provide instructions. So real briefly, let us look at this instruct layout. Basically here we've got another base editor type. In this case it's going to bring up an instruction layout, and it will also have a couple of menu maps, one for returning to DBX tool and the other to start the instructions. Now we're actually going to animate these instructions, and to help us with that we're going to have a FAD layout over here. Now there's not a lot of options to FAD, so let's go ahead and create the prototype. And again, it's creating all the necessary files for doing this application, short of the C functions which need to be written. And here we are. This is the file we had already created before, and this is our FAD layout. As you can see, now FAD has various options for animation and animating portions. We animated the whole thing at this point. Let's see, it basically shows what the DBX looks like and steps through it somewhat. FAD animations are achieved simply by pointing one place, creating lines, and then moving them, and then going between different frames, and the program will interpolate. And how this is used we'll show you in the final product. Show you briefly how these things are tied together. We'll bring up the editor on the C program. Does these instructions, and basically we have a table indicating the lines over here and the corresponding frames over here, and very simply the start show function goes through. It calls a function to enclose the particular lines and lengths we're dealing with, then calls the FAD aniframe function to animate the section of this over here, asks the user to return to continue, and then it takes away the enclosure of previous line, and it basically just loops through the table providing instructions. And that is the extent of the amount of C needed to do this instruction. Finally, to go back to DBX tool, all that needs to be done is a call to GLOW init to DBX tool. DBX tool defined simply as the name that we used to originally create the file. Basically that. So it calls in dbxtool.glow. If it didn't already exist. In this case, it did already exist, and the bringing in is even faster. So let's get rid of these and show the final application. Alright, this final application was put together by using a program called GLOW Combine. And what we did was we said GLOW Combine, DBX tool, and instruct. And what it did was it took the various files that GLOW produced when it produced those programs and combine them into a major file that was then capable of compiling both applications. As a matter of fact, it also combined the make files involved. And so with that, together with the C routines that we wrote, which is in the appendix of the paper accompanying this tape, we were able to produce this program. Now notice this looks quite a bit like our earlier prototype. We have a few more files up here because when we initialized, it went through, it looked for all the .c and .h files in the current directory and put them up here. So we can click on a file, say andu.h for example, and it will go off, read it into memory, and display it, along with a little garbage, probably because of this strange typeface we're using. Let's try redisplaying, clean that up. Now, one of the features of this is that now all of the command buttons down here actually do something. And mainly the commands go right over to here. So if, say, we click on the status command, it will put status over here, and at the moment there is no status because we haven't done anything. However, we could say something like stop at, type in 86, and it'll put the appropriate stop in the appropriate program. So now you might say run, give an argument, and it will run the program and stop. Now, if you remember, we are interested in lines like this. Say this is where if we had a core dump, it would come up with DBX would come up with some line like this telling us where it died. So all we have to do is click on the line, choose our find file option, and the program will read in the file it's dealing with and send it at the top. Alright. Similarly, once we have this information, say if we say we want to stop here, we come down, type stop at current line number, and it will put in the line number from there, and it can even hit return and put in an additional stop. So here we have a fairly useful program produced fairly simply. I haven't shown you the actual C code that tied all this together. However, it is about 120 lines of code, and as I mentioned, in your appendix. Now, the other option we have here is, if you remember the instruction layout, we simply choose the menu option for instructions. Wait a moment while it reads in the other GLOW file and puts together the layouts. And there we are. So at this point we can click here, choose the option to start instructions. And if you remember our about 10-line program before, is doing everything it should. It brings up enhances our first line, illustrates it on the right, and by hitting return we can basically go right down through the instructions, including a little animated Snoopy over there. And finally, down here it tells us to use the menu to return to DBX tool. Thus we have a new application with a minimum of new work.